Good afternoon, everyone. I'm Iraj Sodagar with Tencent America. I also act as MPEG DASH subgroup chair, also president of DASH IF Industry Forum, DASH Industry Forum. So I want to give you an update on what's going on in a standardization front, both in MPEG and also the activities in DASH IF. The good news is that some of the speakers already talked about some of the activities, so I'm going to skip on those, and we're going to focus on the things that we haven't discussed yet. So, the most recent published MPEG DASH standard is 3rd edition. It just got published officially at the ISO site. It hasn't been uploaded as a public free available copy of it yet, but the 3rd edition basically is 2nd edition, which mainly a lot of people are using, plus 4 amendments and 2 core addendums. As you guys know, a lot of those technical works, amendments and core addendum was finished about a year and a half ago, and just the publications of the 3rd editions took a little bit more time, both in terms of integrations and also going through the ISO process. But you can go and get this document. Hopefully, soon it will be available in the ISO free specs, so you can get it, just download it free and see. But it has all the tools that has been developed during the last 5 years, between 2014 and now, and lots of those tools already being implemented and used in deployments. But after that, after the 3rd editions, we work on Amendment 5 and also Core Agenda 3. Amendment 5 had lots of new tools, which I'm going to talk about it a little bit today. Also, Core Agenda 3 basically fixes some of the issues, clarifies some of the issues. We saw some discussions about transitions between periods. We saw some discussions about low latency and the use of segment timelines for it. We're going to talk about those fixes. The good news is that the development of those are done. We're going to basically finish drafting the specification for the editions in a couple of weeks, and hopefully it's going to officially be published by the end of this year or early next year. So let's talk about some of the new tools, the new features in the 4th edition. We'll talk about latency, and clients should not always join at the same time. Depends on the bandwidth availability and depends on the network conditions. They may join at different times. At the same time, for a long time, we have these questions that how content provider can signal what should be the range of desired latency, how far a client should stay from the live edge for a streaming. Some people use this MPD suggested delay attribute, which actually is not the right attribute to use. That was intended just for suggestions and used for synchronizations between different players. So we developed something called service descriptors. It could carry it in MPD or outside of the MPD, and it describes information to the client about the desired range of latencies. So it has parameters like target latency, maximum latency, minimum latency. It even defines in terms of what type of quality you get depends on the different latency you can use. And more importantly, it also provides a reference for calculating the reference latency. In the new specifications, specifically, we used a box in ISO-based media file format called PRTF, which basically can carry the exact time of either the capture or the encoding time of a frame. And you can reference basically a PRTF box in your stream and say that would be the anchor for calculating this latency. So a client can drive actually the exact not only derive the exact latency of a screen-to-screen latency within playback, but also it has a reference for targeting using a target-based latency. This service descriptor latency also used in low delay dash specification. We're going to talk about it dash IF, but when we was talking about dash low latency, one of the use of this latency descriptor is in that use case. There are other service descriptors like quality. You can define a range of quality for the client, a minimum quality rating and a maximum quality rating. In fact, you can define also in terms of the switching between different representations, what's the maximum range it's desired for a client. Now, the question is that if you want to do that, why not just limit the number of representation? The reason is that along with this service descriptor, there is a descriptor called a scope, so you can say that for this group of the client, I want they operate in this range. For this group of the client, I want they operate in a different range. So basically, with a single MPD, you can target different class of the client with the different quality operations, working in a different range of the quality. Same thing for bandwidth operations. You can basically define the different classes of bandwidth. This is good when you have basically premium client versus low or average client or public available client or regular client. Basically, you can define a minimum bandwidth, a maximum bandwidth, and also a target bandwidth. And also, of course, that could be for all the media types, or it could be targeted to a specific media type, like video. Another feature that we added in edition 4, it's the issue of being able to signal what comes down in the line, especially in the live case. Especially in the case that Rohit was talking about switching between unencrypted and encrypted content. If you can signal some of the needed capabilities for the client, first of all, it can decide whether it can play that content, chooses the right decoder if it has multiple decoders, for instance, to play the content, and also prepare for the content it's coming. For instance, in the case of DRM and getting the licenses, it can go ahead and derive it licenses. In the case of on-demand, it's simple. You have all the periods, so as soon as the client gets the MPD, it can look at it and see what it needs to play even before starting playing back. But in the case of live, since all the content is coming as becoming available gradually, the periods is showing up in MPD as Zach was describing. So we have a method basically signaling what capabilities you need. And this calls basically initialization sets, groups, and presentation. And the set basically signals the requirement of playback of one adaptation set. The group signals that for all the periods, for one media type, what capabilities you need to be able to play that content. And the presentation is basically describes, in order to have a complete media presentation, say audio, video, if in the case of the time text, what codecs, what DRM, content protections, and what other capabilities you need to be playing basically the content. The way that this is done, it's not very complicated. In fact, initialization sets is similar to the initialization segments. We use exactly the same syntax. Basically, we define the attributes for the initialization sets, and initialization groups and initialization presentation is basically grouping of these initialization sets, and I will show it in one of the slides how it works. So as I was saying, initialization sets is very much similar to descriptions of adaptation sets. It does not have the resources like the segment links, the segment templates, segment timelines, but it describes for instance, what type of the content type is, the maximum width and maximum height that it needs to support, what type of the codec it needs support. So as soon as a client sees this initialization set, even without seeing any period, if it can basically play back this one, it knows that it can play videos that, adaptation sets that conform to this one through the entire sessions of the live content. In terms of how the capabilities are signaled, say for the video, the MPD consists of different periods, consists of different codecs. Maybe there is a period with AVC and HEVC. Maybe there is a period with, say, VVC and AVC. And maybe there are some periods have adaptation sets with AV1. So initialization groups, all it does is basically says that in order to play video, what combinations of these codecs you might have. Now, in the simple case right now, in many deployment, people are limiting the codecs they are deploying. Just for instance, it stays always in AVC. But in the deployment that is becoming more and more, there are contents, for instance, encoded in HEVC, but the ads might be in AVC. So this multiple codec environment that one period may come from has one codec, and another period a different codec, it's becoming a reality. So this way, basically, you can signal to the clients that in order to play the whole live sessions, what video codecs you need to have. Also, you can say that alternatively, because adaptation sets might have multiple video codecs, if a client supports initialization group 2, which say it's AVC and VVC, it can also play. Same thing for audio. Again, basically initialization group defines what capabilities the client needs to play for the audio. Same thing for time text. And basically grouping the IDs of this, basically using just the ID tags, listing the ID tags at each level. At the initialization presentation, you can say that if you support, for instance, AVC and HEVC, and if you support AAC and IMSC1, you can play the entire content for the live content. Another feature we added is the failover content. There are there was a talk with Yuri. Yuri was talking about how to make live deployment robust. And in many cases, for instance, an encoder goes down or a feed goes down. So there is no content coming in. We did not have any method of signaling that when in the ingest, after the content get ingested and then published, there might be some durations of the representations don't have any content. So there is a mechanism now to signal the failover content. The value of that is that if a client gets a manifest, and while it's playing, it sees there is a durations of a representation that has failover content. Since that representations, that renditions might be created by one encoder, and that's the only that encoder is going down, the other representation might have the content. It can switch to the alternative representations and play the content, and not get either when it does HTTP request 404, or not get just a blank screen or default screen. So not only we can signal the failover content, but also we can signal, in the case of the failover, whether that content is replaced by, say, a blank screen or an empty segment, or it actually, there is no segment available, so the client should not go and request those segments. So these are basically 3 tools I mentioned in 4th editions, but the list of tools are long. There are at least 15 different tools. Some of those are fixes, something like exact placements of the content in the period. We put some additional constraints when you're creating content, that periods should have all the segments. Basically, the media segments should cover the entire period. Previously, it was a little bit relaxed. That was causing problems, gaps, when you're going from one period to another period. That's going to solve some of the period transition difficulties that client has. So with tighter content creation rules, basically we solve that problem. There are solutions like leap second signaling. So if an encoder goes through the leap seconds, you can signal it to the client that this leap second happened at this moment, so the client can adjust its timeline for the leap seconds. There are new device metrics, additional role values, like karaoke. You can signal whether this content for instance, is the karaoke content. I talked about the missing segments and so on. So in 4 editions, you get a good set of new tools and capabilities that it can support new use cases. As I said, we are right now working on the final draft, completing the final draft. It's going to go out in hopefully the first week of August, and going through the process, one more voting, and it will be published in maybe by the end of this year, maybe January, February next year. Besides 4th edition, there is still in Impact, there is some technical working going on. One is Amendment 1. It's about, we are developing more timing model for event and time metadata processing. There was some discussions about in-band event. Application events are also used to carry, for instance, scores. DVB is using it for downloading fonts and also accessibility informations. Time metadata track is becoming very popular. So Amendment 1 is addressing basically a more accurate timing model of that. There are 2 dispatch modes that impacts how you create the events and how you can use it for the application. So that is described there. We are defining a specific dash profile for CMAF. So basically this provides not only the guidelines, but also the requirement how, when you generate a CMAF content, how to generate a dash MPD for it. So that's going to help in terms of convergence between CMAF and dash, and basically using the same media formats for HLS and dash. And there are also technologies under considerations. I will talk a little bit about it. Zach talked about MPD patching. That is one of those that is being considered. It's not listed here. There is also a new part 8, that I will talk about it, called session-based operations. So I talked about event and time metadata. Event MPD dash events, basically you can have events in MPD, or you can add to the beginning of the segment in-band events. They are very powerful in the sense that, either it could be completely independent and media, you can describe it in the MPD, or as you're creating the content, especially for the live case, you can carry it as a part of the in-band event. So if the client gets that event, for instance, to do MPD update, it doesn't need to pull MPD all the time. As soon as it gets it, it updates the MPD, or it can carry other informations for the application. So we are defining the timing model, especially in the sense that how it can get consumed by the application, whether it's dispatched immediately as soon as the client retrieves the segment, or it should wait, process the event timing model, finds the start time of the event in the media timeline, and dispatch it at that time, what we call at the start dispatch mode. And for the sparse time metadata track, when you have all those information as a separate track, the same model can work. So those are all described in this, and this shows basically 2 dispatching mode. One, what we call on receive, when the client, as soon as it receives or retrieves the segment. One, as I said, the actual starting point of the event in the media timeline. The reason for knowing the dispatch mode is important is that because when you are developing events for applications, you need to know when you're creating those events, how it's going to be dispatched to the client, to the application, so its impact, how you create that event and what you put in that event and in the timing of the events. I talked about Dash profile for CMAF, basically talking about the normative mapping of the CMAF to Dash content, as you guys can imagine. CMAF switching set, how they are basically mapped to adaptation sets, what type of period constraint we need to put, transitions between period and period connectivity, segment addressing schemes, content protections, what type of signaling you need to do when common encryption is used in CMAF, and also the conformance requirement. Now, also, there is a new part in MPEG standardizations of Dash. We call it session-based Dash operation. This really started from, Ali is the editor, and it started from a use case that they wanted to include, they wanted that segments basically carry or create a watermarking. So for each client, even with the single MPD, the client goes and gets different alternatives of the same segment, slightly different, and just these variations of the segment, how they are put together, it creates a signature. So what we have created is basically a model that you have an MPD, you have some external information, we call it session-based description, that tells the client when it requests a segment, what additional operations to do, for instance, add a query to it, and what type of the query to add, to be able to all do, basically get different alternations of the same segment, and building that type of, for instance, forensic watermarking. That's one of the main applications. This is a very new work. It's developing. It's still in the working draft. I encourage people to join and participate this. The main feature of this is that the MPD is common for all clients, but you can customize these operations per client or per class of client using an external file. So in terms of the cacheability of MPD, it's not going to impact the CDN efficiency, and also just generations of a single MPD for all the clients. It's going to save a lot of processing. So that was the activities in MPEG Dash. Dash Industry Forum also has its activity. As you guys know, the way Dash Industry Forum and MPEG work together is that Dash Industry Forum was created to basically foster adaptations of MPEG Dash. We wrote guidelines. We put more constraints on the Dash specification. We tried to create more constraints to achieve interoperability in between different implementation. And as you can see, there are different threads, different tracks in Dash Industry Forum. There is this IOP track that publishes guidelines that put more constraints, also add video codec, audio codec specific, the signaling for them. So it makes it, the Dash specification more practical to deploy. There is a conformance tools, and there is a test vector database that probably is the most comprehensive test database that you can find in the, on Dash, and also it has the conformance tools. You can run it either on web-based API, or you can download it and basically run it locally. We supporting Dash.js development that has been used both in terms of as a reference player as well as a deployment player. There are activities like CPIX, which is basically a content protection signaling format, information exchange, basically XML method between, or format for exchanging between, say, on the server side, between the encoders and DRM license servers, or encryptors and DRM license server. This has been very popular. So right now it's at version 2.2. It's going to go to ETSI for formal standardization, and so on. So if, for instance, every week we have something like 5, 6 calls, like add insertion group, calls are every other week, event calls every other week, live and low latency, it's every week. There is a lot of activity going on, and joining and participating, it's easy because you just need to join the call, become a -IF member and join the call. So one of the outputs, recent output is live media ingest. Rafael already talked about that. Low latency guideline, we just published a low latency guideline. I think Will talked about that. It's a joint activity with DVB, uses basically HTTP chunk transfer encoding as well as CMAF chunk, and uses some of the features I talked about in MPEG 4th editions. This event and time metadata API model, it has a client model for how to client process. As you can see, there is a separate track for processing time metadata and events. And also add insertion. One thing, since we don't have much time, is that in this workshop, there was a lot of talk about server-side add insertion. And I think industry is getting very close to how to build server-side add insertion, as you saw in the different examples. But on the client-side add insertions, there are some benefits, at least, that basically with the single MPD, you can still have targeted add. And while still we can support it with the MPEG DASH specification today, I think still it's under-specified. So we are looking for some use cases, and we are working on the solution, both in -IF and MPEG. And the industry input is really valuable here. Valuable in the sense that, for instance, for pre-roll, what type of conditions you have for each client. Publishing a single MPD, does the target, the durations of the ad changes per client? Does the client is allowed to switch after a certain number of seconds to the live program? In the live program, early terminations of ad, is that desirable? Is there a way to signal a minimum durations of ad, or is there a way to signal a notice of when, what's the, like, a head notice or advance notice of terminating the ad? And also, when terminating the ad, is that in the middle of the ad, it could be in the middle of ad, can it transition in the middle of segment, or is it okay always we put the constraint that it transition at the end of the segment? Each of these add some complexity to the solutions we develop as a standard solution. So contributions and providing feedback what's needed is quite important here. There were some discussion today about like multi-period transition, X-link resolution. I think some of our specifications are a little bit under-specified in the sense that, like, when you are creating content with X-link, what type of consistency you need to have in your content creation. When the client resolving the X-link, what type of timing model it should follow. From the implementation I've seen, it seems that people are taking it the way they like it. We need more accurate timing model for this type of behavior to have more predictable behavior. So getting the feedback on those use cases, it's going to help us to see what level of constraint, additional tools we need to add to help, especially in the case of the ad insertion. So, as I said, it would be good to get the feedback on this. I even created a list of the questions, and the red flag is up. You can find -IF resources in this slide, as when Ali send out the slides out. And of course, you are welcome to join -IF. Thank you very much, Michael, for joining. -IF has 80 members. It's one of the most active consortia I've seen in terms of trying to address the market needs and developing solutions. So joining, leading, impacting solution really helps everybody in the industry. Thank you very much.
We can take a few questions. I'm really glad that this room is still full, actually. Wow, that was unexpected. Are there any burning questions for Iraj before we go to the last presentation?
One of the problems I've faced before when working with Dash and the timing model is that the availability start time is usually a wall clock time, and then other parts of the Dash timing model actually come from the media clock, and that those clocks jitter independently and cause segments to move on absolute time. Is that something that the Dash committee has looked at?
Yeah, we looked at it. This PRFT box in the segment format, it exactly tells you the wall clock time of the captured, not even the encoding. You could set up, depends on the option you use. So you can basically say when exactly it's captured, so you can tie the content, the frames, to the wall clock time. Of basically the wall clock time that is described in MPD. Also, we have this UTC timing that basically you can synchronize between the client and the server that created the MPD, so they basically work on the same wall clock time.
All right. Any other question? No. All right. Thanks, Iraj.